Okay, if I give 7 cookies here to Landon, and I tell him to split it up between himself and Ava and Ryan. You sure we didn't talk about this?
Yes.
I thought we did.
We did.
Okay. If I'm splitting up 7 cookies between Landon, Ava, and Ryan, that means I'm taking 7 and dividing it evenly into 3 people. When you do the division here, you end up with everybody's going to get 2 cookies, but then you have this remainder 1 over here. And if I said, Landon, if I asked you to give me a remainder 1 of a cookie, well, how much would you give me, or what would you give me? Well, that'd be a whole cookie. That can't be a remainder cookie. Everybody can't get 3 cookies because there's not enough. So if you gave everybody 2, and then I said, give me the remainder, you have a remainder of 1, what does that remainder of 1 mean?
You have 1 cookie left over.
Right, and you have to split it how many ways? 3 ways, okay? And that's what we're talking about today. I will draw the cookies up for you. We've got 7 cookies, and we're splitting it evenly up into 3 different groups. You know, Landon gives himself 1 first. He should be nice and give Ava hers first. But Landa, Ava, Ryan, they each get 1 cookie. Landon, Ava, Ryan, they each get 2 cookies, and then there's this cookie left over. That's where our remainder 1 comes from. Okay, but in our world, did I get something wrong? In our world, we don't deal with remainders. Has your mom ever told you to give your sister a remainder 5 of something?
No.
No, because we don't have that. So what do we have to do with this cookie here? Because there's 3 people, that was where we have to split that into 3 pieces. Okay, 3 equal pieces because it has to be fair, and then Landon gives himself 1, Ava 1, and Ryan 1. So we end up with 2, but instead of writing this as a remainder of 1, we take and say everybody's going to get 2 and 1. How many equal pieces did I cut that into? 3. 2 and 1/3 of a cookie. Like I said, I thought we talked about this. Everybody kept saying no. Now, rather than drawing pictures, though, because it could get really hard if I said, "Okay, Landon, now I'm going to give you 32 cookies, and I'm going to ask you to split that up into, I don't know, well, 9 people." You don't want to have to sit down and draw up 32 cookies and see what's happening there. How many cookies is there? How many whole cookies will everybody get? How many times does 9 go into 32? Kaylin?
4.
Well, 4 times 9 is 36. So go a little lower than that. Everybody's going to get 3 whole cookies, right? So I end up with a remainder of 5. Again, remainder of 5 doesn't mean anything to anybody. So what is the direction here? How do I get a fraction now? Do you remember? I thought if we talked about this, you would remember. Let's go back a screen.
So how would you do
I got 2. I got 2 here. My remainder is 1. Where did that 1 end up going? Grace? Yep, that 1 ended up going right here on the top of the fraction. P-O-P. And where do you suppose the bottom of the fraction came from? Remember, because there were 3 people, we had to cut the cookie into 3 pieces. Same thing here. This 3 came from here. How many equal pieces you're splitting it up? If we go back to this screen here, and now I have 3 whole cookies split up 9 ways, the bottom of the fraction is going to be always this number out here that you divided by. The top of the fraction is always the remainder. So make sure in your notes you get that going out, because that is how you make a mixed number. The 9 comes from here. How many equal pieces you're cutting something into? The 5 comes from the remainder, so it's 3 and 5 ninths. And that works with any division problem. Let's say you have 16 divided by 5. How many whole times does 5 go into 16? Kayleen?
3.
Yep, and you get a remainder of 1, but we don't like remainders anymore. What's my fraction going to be? Madison? Exactly. The 1 from the remainder and the 5 from the What's that called in division, that guy that does that?
I know. It's a visor.
Divisor. As opposed to the one underneath here, which is the dividend, and this is the quotient. The answer is the quotient. And no matter how big the division problem we do, even if it's like 735 divided by 4, have we done those kind of problems? I think we have.
Yeah.
You know, you do the division problem just like usual, you just know that your fraction is gonna have a 4 on the bottom, because it's going to be this number here. Your remainder is gonna go up here, and your quotient goes there. 4 goes into 7 once. You bring down, 4 goes into 33 8 times, which is 32. And 4 goes into 15 3 times, which is 12. But instead of writing my thing with a remainder of 3, that 3 gets put up top on this fraction up here. So you get 183 and 3/4. Think you're gonna have a problem with that? Probably. They are also going to do this for you. They're gonna give you stuff like this. Yeah, write this down. They'll give you a drawing that looks like that, and they will tell you to write the mixed number for that. What would be the mixed number for this? And again, it gets, fortunately, they're not gonna get real high because they'd have to draw a lot of circles if they were doing big things there. Sammy Bollinger? Exactly, 2 1/4. They might ask you something like, they might ask you to draw 3 1/2. If they tell you to do that, again, you could probably do circles or rectangles. Sometimes they'll tell you circles. So 3 whole circles. You draw 3 whole circles and then 1/2 with that one. Why do I always shade the bottom? Alex?
It's the bottom of the fraction.
Brooke?
Because if it's a water jug, water can top.
Right, but what if it was air and air went to the top? What if it was air and a helium balloon and it went to the top? Yeah, it doesn't matter what side you shade. It doesn't matter what part you shade. I was just seeing if somebody would come up with a good answer for that. All right, that is it, children.
Oh, thank you.
What was that?